Hello, and welcome to Answer Everywhere. Today we're taking a look at uBlock Origin, the ad blocker. This is a JavaScript project. We do have it on GitHub, so let's go ahead and open up GitHub as well. That will give us slightly easier search. We also have a manifesto. I guess let's look mainly in Emacs. We've been doing Emacs. Seems to be doing all right. Should we read the manifesto? The uBlock Origin Manifesto. The user decides what web content is acceptable in their browser. The UBO project does not support AdBlock Plus's Accept Ads Manifesto because Acceptable Ads Marketing Campaign is the business plan of a for-profit entity. Okay. That seems pretty manifesto-y. What is removed? For convenience, a list of commits of renamed or removed assets so they can be more easily found. Okay. That's a little bit interesting. I don't think I've ever seen that, but in terms of folders, we have assets, which is possibly interesting. I guess we'll mark it, and then source. And I'm guessing everything is in source, except for there might be some stuff in tools. In tools, we have a few make scripts, like make npm, make chromium, make browser. Does Firefox get its own? Make Firefox meta, make Firefox. Okay. So I guess let's take a peek in assets. We have assets.json and then resources, scriptlets. So these are like helper functions. Seeing stuff about send to logger, some run ad stuff. Okay. We may come back to this or we may just kind of ignore it for now. And so let's take a look in source. All right, we have 1P filters and 3P filters. P being, I'm not sure. I don't know if this is like arity, like one argument versus 3 arguments. We have about.html, which I'm going to guess is about the project. About contributors. Yeah, so this is just an about page. We have a cloud UI, a code viewer, some CSS, I'm going to guess mainly for, is this all just for the web page? It can't be, right? We have Dyna rules. Is this just documentation? So Dyna rules is calling a bunch of scripts, including swat enum, labdiff swat enum, code mirror.js, merge.js, and some other stuff. So what was that in lib? I don't know what any of this stuff is, but we have a README. Let's look at the README. Code Mirror is a versatile text editor implemented in JavaScript for the browser. It is specialized for editing code and comes with over 100 language modes. So maybe this is support for the UI. Do I have uBlock installed here? Yeah, this is it, right? So somehow, some of this stuff has to work. So let's block. What should we block? I guess let's block. I don't really want to block anything that I want to see. What's an annoying page? How about LinkedIn? Let's just block random things on LinkedIn just to see how it works. So I can turn this on or off. What does this do? This is click to block all pop-ups. We can block large media elements. We can disable cosmetic filtering, block remote fonts, and we can disable JavaScript on the site. We can report issues, open the logger, open the dashboard. So so maybe for rules is possibly where we get some of the code editing stuff. Like this, maybe this is part of the code editor because we have like syntax highlighting and whatever baby bear is. But I guess I can pick this or create it. How do I block this whole thing? create, and that'll block that. So maybe this UI is sort of where some of the code editing and stuff is. But let's see if, so CodeMirror seems to possibly be an independent project that is being imported into the uBlock project. CodeMirror. Do we get screenshots? Is this a screenshot? Let me try disabling. Oops. Let's try disabling the dark reader. Seems to have no effect. All right, whatever. This purports to be a screenshot of CodeMirror. Okay, so we have CodeMirror that's somehow for editing code, presumably mostly HTML. We have CSS Trie. Do not use SRI with dynamically generated files. For more information, look at this thing. Look at whatever this thing is. I don't know what this is. CSS Trie. Maybe we can. We've got some license. I'm wondering if lib is largely other projects. We have diff, swatdenum diff, implementation of Meyer's diff algorithm. And we have links. So as in CodeMirror, I didn't mention it, but I saw that there's a link to the Travis CI for, I guess, CodeMirror. And similarly for here, I don't really know what coverall is. I guess this is some coverage status. Oh, these are like the buttons that show up on like GitHub. Oops, don't do that. So it's an O of ND difference algorithm and its variations. All right. And since this is, do we have a GitHub link here? Let's look up swat enum diff. Yeah, this is its own project. So at least so far, these things in lib are other projects. So LZ is also JS Beautify is presumably some sort of like pretty printer or beautifier. Public suffix list with some WebAssembly stuff. And then what is .what? I'm not sure what this is. So something about car data I32 is node I32 offset to current blah, blah, blah. Oh, this is like a WebAssembly file, right? So what about the JS file? An efficient JavaScript implementation to deal with Mozilla Foundation's public suffix list, which is here. And you get to pick which license suits you, the GPL v3 or the AJPL v2. And this is a different repo, but it's by the same developer as uBlock Origin. Is this just like file formats? The list. Oh, see the list. Okay. Arrow, club.arrow. Huh. Are these AF? So somehow these are like top level domains and a bunch of, I guess, domains in them. So we have com. Under com, we just have Wikipedia. Oh, no, this thing. Wiki.com. I don't know what is going on here. We have the wiki. What if we click on learn more? Is a cross-vendor initiative to provide an accurate list of domain name suffixes maintained by the hard work of Mozilla volunteers and by submissions from registries. we can see the usefulness if we take the example of cookies. In the past, browsers used an algorithm which only denied setting wide-ranging cookies for top level domains with no dots, for example, com and org. However, this did not work for top level domains where only third level registrations are allowed, for example, co.uk. Okay, so this gets around some issues with having to come up with your own algorithm for understanding the structure of URLs, essentially, is what it looks like. And we have the algorithm here, match a domain against all rules and take note of the matching ones. If no rules match, prevailing rule is star. If more than one matches, etc., etc. So this is maybe for, I don't know if this is for like defining rules based on the domain name. But that's some stuff in the lib. Here's JS. This is where I guess a lot of the gold will be. So we have settings we can ignore, about we can ignore, assets we'll mostly ignore. These filters, ones I assume are important. Cloud UI might be important. Commands. Let's see, cosmetic filtering, maybe. A bunch of dashboard stuff, some dev tool stuff. Dynamic net filtering. DOM.js is going to be some sort of DOM handling or DOM modeling stuff. We have some, whatever HN switches is, HN Trie, or Trie, I think is how you're supposed to pronounce Trie, and I assume that's going to be some sort of tree or try implementation. Header filtering, HTML filtering is almost certainly important. Messaging, I don't know. MRU cache, as opposed to an LRU cache, I guess should be the most recently used cache. So LRU cache usually kicks out the least recently used. So I'm guessing most recently used cache would kick out the most recently used. And then we have a page store for storing pages, I suppose. Pop-up Phoenix. I think Phoenix is somehow related to Firefox. Maybe it's Firefox pop-up stuff. Reverse lookup, presumably for like DNS, reverse DNS. Scriptlets is a whole directory of little scripts. We peeked at it. I'll mark it in case we need to. I'll mark it in case we need to look more at it. Text and code theme is not so important. Maybe we'll look at uBlock.js, traffic.js, and there's some WebAssembly here, which is a bunch of trees, Trie trees, including the HN tree. I don't know if this is exactly the same. Before, the other tree had an HN prefix, or an H prefix. I don't know if it was HN or something else. Then we have a BiDi tree, presumably a bidirectional tree. And let's look up tree and see how it's supposed to be pronounced. I think it's pronounced Trie, same as the idea was independently described in 1960 by Edward Fredkin, who coined the term tree, pronouncing it tree after the middle syllable of retrieval. However, other authors pronounce it as try in an attempt to distinguish it verbally from tree. I'll call it a try if that's acceptable. All right, and let's see. I guess I'll let me disable dark reader here. It's going to be blindingly white, but at least we can see the diagram. So it's a k-array search tree. We've seen them before, and I think it's the same as is it the same as a Patricia tree? Somewhere? Patricia trees are a particular implementation of the compressed binary tree that uses the binary encoding of the string keys in its representation. Okay. So we have keys. I guess maybe Patricia trees maybe only have integer keys. I'm not sure. But it's basically a generalization of the binary search tree, except we have possibly more than two leaves. And if you want to find, for example, 10, you go first to T, then to TE, and then you go down the N. And I'm not sure what 12 represents here. Oh, I guess a 10 is the key and 12 is the value. Is there anything else to know? A tree data structure used for locating specific keys from within a set. The keys are most often strings with links between nodes defined not by the entire key, but by individual characters. In order to access a key, to recover its value, change it, or remove it, the trie is reversed. The trie is reversed depth first, following the links between nodes which represent each character in the key. Okay. Good deal. And then what is a BiDi tree? BiDi trie. I'm not sure. But maybe you can search from both directions as opposed to just from the root or something. So let's look at maybe 1P filter first. We're importing code mirror ubo static filtering.js. I don't know. Okay, so code mirror somehow is, at least we're using one of its libraries possibly for filtering. And we're getting a new code mirror. So I think this is mainly for adding filters. We've got some linter. It looks like lint gutter. Let's look up uBlock origin, add filter. So I think this is possibly UI stuff. Kind of maybe looks like this. We have some entries. That's some list. And maybe the code mirror stuff is like where you enter your code for the filter, which is, I'm guessing, some sort of like regex type language. So let's look for a uBlock origin custom filter. How about this tutorial? Custom rules on the fly. We have, so we have some wiki. You can use regex-based values as target domain for static extended filters. For example, this regex, use sparingly when no other solution is practical from a maintenance point of view, keeping in mind that UBO has to iterate through all the regex-based values, unlike plain hostname or entity-based values. So this is, I guess, for deciding which domain names match a specific filter. But somehow there's like the deciding what to filter from the website is implemented in some language. I don't know what language that is. This probably some HTML path language, right? Let's try uBlock origin path language filter. I'm not easily finding like what this language is called, but maybe we'll come back to it. At any rate, we have some code mirror stuff. Autocomplete ability to the editor. So this is still editor stuff. Why is it 1P filters? I don't know. And stuff like remember current state, user filters change. This will, I guess, indicate when the filters have changed so that you can, so that you can be sure whether you have saved all your changes or whatnot. We have a three-way merge, passing in the new content. I don't know how what new content is under the hood. We don't have anything like types. But new changes, we're going to split at, I guess, new line. to get new changes, and then we have user changes, and then original state was somehow we have access to the original state, I guess as some ambient variable. Merge changes to the user filters occurring in the background of the changes made in the editor. The code assumes that no deletion occurred in the background. Okay, then we can also render the user filters, and this all seems to be UI related stuff. And all of that's fine, but I'm not really here for the UI. This is 3P filters. Last update template has own property, whatever that is. And then we have this on broadcast thing that says, that seems to be like some sort of messaging system, like whether an asset was updated, in which case we will call this message update asset status, passing in the message, which presumably tells you what the new update is. And similarly, if you have assets updated, I'm going to guess this means multiple are updated, then we're going to call DOM CL. I don't know what CL is, but we're going to call remove DOM body and updating. And then we're going to render widgets. So I guess we do a re-render. And then if we have static filtering data change, then we call render filter lists. And I'm not sure if this is re-rendering the original page or just re-rendering the page where you edit the filters. And then we have stuff like on list change, toggle filter list, update node list. I think this is probably still stuff for editing the filters themselves. What is Cloud UI? I don't know. We have this cloud widget. Fetch storage used. So I'm going to guess this is like you can store your filters possibly on the cloud. uBlock origin cloud support. Cloud storage. Yeah, okay. You can store your stuff on the cloud. That's not so exciting. I'm not going to look at it. So commands. Relax blocking mode. What else? Something about adding listeners, dashboard stuff. But where's the stuff that actually handles the filters? That's what I really want to see. You have the select cacher entry thing. Key from selector. Hash from string. Cosmetic filtering engine prototype compile. So this looks like it's compiling something, presumably the filter. It's a function of the parser and writer. And if the parser has if the parser has no options, then we compile the generic selector and return true. Otherwise, we set apply globally to true, and we get the filter domain iterator from the parser. And if bad, then continue. I'm not sure what bad means. Some sort of parser error, I assume. And if not is false, then I guess not tells us the status of apply globally because we set apply globally to false. And then we call compile specific selector as opposed to compile generic selector. And the thing we pass in is the parser, the HN, not, and writer. So whatever HN is, I think it's probably related to HN tries. So I don't know what HN is, but then if we are applying globally, then we call compile generic selector on the parser and the writer, not passing in any HN. So let's take a look at compile specific selector. So compile specific selector is a function, takes a HN is host name. So HN trie must be a trie of host names. Good to know. And So we get the parser result, which has raw, compiled, and exception. I guess exception is the same as bad. So if compiled is undefined, then we do some stuff. We try to get the name from the writer properties. And if so, we log an error message saying that it's an invalid cosmetic filter. So if and we return. But if we don't have this error, then we call writer select on cosmetic filters specific. So whatever the writer, we're presumably setting some sort of specific mode on the writer since we're in the specific compile part. And we might hide some stuff depending on whether there's an exception. We set the kind to 0. And if we don't have an exception, then we look at the character code at the beginning of the filter, I suppose. And if it's OB010, then it's a procedural filter. And if the host name is star, then it applies everywhere. And then onto the writer, we're going to push 8. What 8 is, I don't know. The host name, the kind, and compiled. And compiled we just got from the parser. And then we have this ability to get from compiled content of a filter, a cosmetic filter. And we select specific filters from the reader, which is, I guess, like dual somehow to the writer. And while we have more content left in the reader, we increment the accepted count, and we call fingerprint on the reader to get a fingerprint. If this duplicate buster has fingerprint, I don't know what duplicate buster is. I guess duplicate buster is a thing that busts duplicates. Then we call discarded count. Then we increment discarded count, and we just keep going. So we just say that we're discarding a duplicate, but it doesn't seem like we're like deleting the duplicate from wherever the duplicate lives. So I'm wondering if you have duplicates, it just forever just adds work to your thing. I don't know. And then we add the duplicate buster, the fingerprint to the duplicate buster. So now duplicate buster is essentially a dictionary of things that we've seen before. And here we're just checking, have we seen this before? And if so, don't do any more work. And then we get args from the reader and switch on the args. And if we have case 8, which is the case we wrote above here, it's like a magic number. If args at value 2 is OB100, which is this, I guess that means host name applied. Host name is everything. Then we look at args 3, and we might say it's highly generic simple dict add, or highly generic complex dict add. So 3 somehow tells us simple versus complex. And then at the end, we call specific filters store on the arguments. And by default, we just call discarded count +1 and break. So that means that arg0 is not anything we care about, I guess. We only really care about 8. Whatever 8 is. And then we can do some more stuff like skip. If we need to skip generic content, we might call skip content on this generic string. And then I guess up here we looked at for specific filters, and then down here we must be looking for generic filters, and we do something similar. Lowly generic. I guess highly versus lowly. Is that the idea? Okay. So that's at least, we're now looking at something that looks credibly like we're dealing with filters. Let's look at reader and writer maybe. Do I not have C tags, or is it just not supporting JavaScript? Let's try to make sure we have tags. For whatever reason, even after I generate them, they're not working. See if GitHub is any better. Is maybe reader and writer are generic JavaScript things anyway. Also, let me make sure that this is updated. Okay. I'm not sure. So what are some of the functions that reader and writer have? Writer dot properties dot get, writer dot push. How about we look at select? Maybe cache storage. vAPI background. For background page. Yeah, I don't know. I don't know what type these readers and writers are, but at any rate, we do see some of the structure here. We have things like skip compiled content. Which is just calling stuff on the reader and writer. So for example, skip compiled content is just calling select on the cosmetic filters with this section ID that's passed in, and then while reader has next, I guess reader select says we're only going to look at this subset, and while we have next, we'll say we've increased the accepted count and also increased the discarded count. I don't know why we're increasing both, because I guess we accepted and then discarded or something. Okay. So that's interesting. Let's see what else we can find. Since we can't jump around really effectively, let's like continue looking at sibling files and seeing what we see. Let's look at DOM. We don't really have a lot of comments anywhere. So DOM has normalized target. If type of target is string, then we get array from QSA target. And I'm not really sure, it's some sort of juggling with targets. We can make an event handler, which is just a function that takes an event and has some dispatcher. And then the DOM is a class that has things like attributes, the ability to clear. So what happens if we call clear target? We're going to loop over the elements of normalized target. And while the first child is non-null, we're going to remove it. And I guess after we remove it, the second child now becomes the first child. And we are calling normalized target. It seems like everywhere. Is that what we want to do? If we're going to call it this frequently, essentially we're taking or creating an array from the target. Is the target the same as the page, the DOM? Or so if the target's a string, I don't know what QSA is. If it's an instance of element, we return a list of the target. I guess a singleton list containing only the target. If the target is null, we return the empty list. And if it's an array, we return it. It's already an array, return it. And otherwise, we call array.from. So if target is like some tree, I guess, then it's supposed to be like get down here and handle this array. And so I think that what we're doing ultimately is we have functions that want to take arrays as input, and we're just coercing all of our inputs into arrays, which seems like that might not be the most efficient way to do it, but maybe I don't know much about JavaScript. I'm not sure I'm understanding really what's going on yet. So we also have this function on, which takes a target, a type, a subtarget, a callback, and options. And it says if the subtarget is a function, if the type of the subtarget is a function, we set options to callback to subtarget, and subtarget to undefined. And if the option says type Boolean, then we set options capture true. Otherwise, we set callback to make event handler of subtarget callback, where this is the callback that was passed in. And if options is undefined, or if it's of type Boolean, then we set capture to true. I'm not really sure. Really, I mean, all this, the code locally makes sense. I'm not really sure what it's up to, especially given the lack of comments. Some sort of operations with DOMs on and off. Off is going to do what? If the callback is not a function, we're going to return. So I guess we only care about functions, or rather callbacks that are functions. And then if the type of options is Boolean, we set capture to true. I guess maybe that's the default. If it's an instance of window or an instance of document, then we're going to return a list containing target. Otherwise, we're going to call normalize target. I'm not really sure what a target is. And then we have QS and QSA, which you saw above, query selector all. Okay, so if we pass in a string above, we call QSA on it, and that ultimately is calling document query selector all. So that's beginning to make more sense. So that's essentially selecting the elements, I guess, matched by that string and returning them as an array. So if we pass in, I don't know, like the anchors, then I guess we're like finding all the anchors or something. And if we call clear on them, then it's like deleting the anchors or something along those lines, which would kind of make sense as a way of doing filtering. Dynamic net filtering. We're importing puny code, which I assume is some sort of code minimizer for JavaScript. Supported dynamic types. We have 3P. I don't really know what that is. We have image, inline script, 1P script, 3P script, 3P frame. I don't know what these things are. Third party. Okay. So 3P is third party. Type bit offsets. Inline. So these are some bit offsets, maybe to define some sort of like custom protocol. A name to action map. So block is set to 1, allow is set to 2, and no op is 3. And then int to action map, I guess, is the reverse map. Bad host name for performance purpose, as simple tests as possible. So we have this bad host name thing that I guess is going to like look for things that start with a number. I'm not sure exactly. I think this is a number followed by a letter, although there may be grouping. And then followed by like multiple slashes. I think this is some like grabbing the slash content somehow. I forget exactly what this is. Let me ask AI to explain this regex to me. I was like, explain this regex in simple terms. Match any character that is not a lowercase number. Or So indicates a negated character class. Okay. Yeah. But I think without the square, the caret means like begins with, right? It anchors the pattern at the beginning of, okay, so didn't realize that if you do the caret within a square, it's not the anchor thing, it's the negation. Okay, fine. So this is like the negation of a valid URL. This is the negation, I guess, of ASCII. And then we have decomposed source and decomposed destination. I'm not sure in what sense we're decomposing them, but we're somehow decomposing them. And they were calling is third party. Given the source name and the destination name, I guess we're probably just checking if they're the same party. If at least one is partyless, the relationship can't be labeled. Okay, so if they're star or empty string, I guess, then there's something we can do. Otherwise, we call domain from host name. And if the destination host name ends with the source domain, or rather, if it doesn't end with the source domain, then we return true, that they're third party. And we're not going to confuse example.com with another example.com. By doing what? We're checking whether they differ by a dot at the appropriate place. Okay, and then we have this class dynamic host rule filtering with some constructor, which is just going to call reset, and reset's going to, I guess, reset all the state. So if you add a new state, I guess you need to make sure that you add the appropriate thing to reset. And then assign on other, remove rules not in other. So this is some sort of like merging behavior, it looks like. Then we can copy rules. You can check if we have the same rules. We can set a cell given a source host name, a destination host name, a type, and a state. And we have this bit offset thing that we pass the type into. And we set K to be this. It looks like we're just doing string interpolation, the source name and then the destination name. The old bitmap is going to be this rules get K or 0. And new bitmap. Okay, so we're storing stuff in bitmaps. K must be the key. And I guess this is maybe looking up the value of the key by ORing it with 0. And then the new bitmap is going to be the old bitmap, and we're going to AND it with the we're going to shift the bit offset by 3, negate it, and OR that with the bit offset shifted by state. State was passed in. Three, I'm not sure. Oh, yeah. Okay. So, and then if the new bitmap and the old bitmap are the same, we return false, I guess false indicating that we haven't made a change. Otherwise, if the new bitmap is 0, then we're going to delete the rule. I guess because it doesn't match anything. Otherwise, we're going to set the value key to the new bitmap and say that things have changed. Return true. What I don't understand yet is what is the bitmap doing? So for each, the key is what? The key is a source name and a destination name. So somehow it's keyed by like a pair of an ordered pair of host names, where I guess the source host name is where we are as a website, and the destination host name is like where is the possibly third party thing that source host name is calling. So if you're at I don't know, LinkedIn.com and they're importing fonts from Google.com, then like LinkedIn I think would be the source host name. Google.com would be the destination host name. And if you wanted to block those fonts, you would add some sort of rule saying you don't want LinkedIn to grab stuff from Google. And that would somehow populate this set of rules. And the rules consist of bitmaps or something along those lines. No. So the rules should have rules for all host name pairs. And in getting at K, at this particular key, we'll get the things that govern whether LinkedIn should pull from Google in this example. And that corresponds to some bitmap. And the bitmap is essentially it essentially contains the information I think about type and state, because we get the bit offsets from the type, and we use the state in computing where to put the bit. So this bitmap is essentially like a hash map of type and state conceptually, I think, if I'm understanding it correctly. And correspondingly, we can unset the cell. We can evaluate a cell. So to evaluate a cell, we pass in the type, and we have the same key. We get the key. Presumably the rules are in this trie thing. And if the bitmap is undefined, we return 0. Otherwise, we take the bitmap, shift it over by type bit offsets, evaluate it at type, and we AND with 3. 3 being what? The last 3 should be 1 1, right? The last 2 digits. And that gives us the thing we're returning, which is possibly just state. And then we can also clear registers, evaluate cell Z. I don't know what Z stands for here. So evaluate cell with a Z now takes, now we call this decompose host name. And we have this.z. And I don't know what any of this is. We now have a circ and a dest host name, source host name, except now we are abbreviating it differently. And where did we get, because we're iterating over some stuff. So we decompose the source, and now we have a bunch of different sources that we're doing the same thing with. And I'm not sure why it's called Z. And then we have evaluate cell ZY, which is going to be a similar thing. All right. We have some stuff about validating rules. So this is verifying things like the ignore hostname based switch rules. ignore URL-based rules. I'm not sure why we're ignoring those. Maybe there's some other code that handles them, and we don't have them in this particular thing. I don't know what a selfie is. We have from selfie and to selfie, and when we call to selfie on what? This is some collection of rules, right? Dynamic host rule filtering. We give it a magic ID, and we put the rules into an array. So I think selfie is maybe some sort of like serialization format. So let's look up dynamic host filtering, uBlock origin. Quick guide. So dynamic filtering overrides static filtering. This means a block dynamic rule will override any existing allow static filters. This means you can block with 100% certainty using dynamic filtering rules. Similarly, an allowed dynamic filtering rule will override an existing block static filter. That is, you can, with 100% certainty, allow with dynamic filtering. Useful to unbreak sites broken by some static filters. So the columns are, the first column is what is to be dynamically filtered. And we have things like all images, third-party, inline scripts, first-party scripts. And I guess that this, this is some of the byte offset stuff we saw, I think. So 3P scripts, 3P frames. And then we start getting into host names. It looks like. As you can see, you can create dynamic filtering rules for resource types or host names according to their origin. The color of an entry indicates whether all requests were blocked, reddish, all requests are allowed, greenish, or some are blocked and some are allowed, yellowish. In bold, domain names. Domain names are host names, but host names are not necessarily domain names from uBlock origin's point of view. Domain names are extracted as per Mozilla public suffix list. And in the second column, we have global dynamic filtering rules. That is, whatever rule appears in the column applies everywhere on all sites. Okay, so this is, I think, pretty consistent with what we saw here. Let's go back to the beginning of the file. So the supported dynamic types, these are the things that we saw. The bit offsets, star is all. Inline scripts, etc. These have different bit offsets, so they go into different places in the bitmap, and they are all 2 apart. So so all starts at 0. Inline script starts at 2. First party script starts at 4. So these are all like 2 digits wide. And then the name to action map. By digits, I mean bits. Base 2 digits. So and then this, so block is represented by a 1, which is 0, 1. Allow is 2, which is 1, 0, and then no op is 3, which is 1, 1. So these are all fitting into 2-bit increments. And so I guess that this is saying, so if you want to know whether to block first party scripts, you go to the 1, 2, 3rd section of 2-bit wide permissions. You look at what the value of that permission is. And then host names is the stuff that we looked at. They're keyed into some rules structure, probably a trie. In fact, let's look at the tries now. Let's look at HN trie. The original prototype was to develop an idea I had about using jump indices in a typed array for quickly matching host names, or more generally strings. Once I had a working, unoptimized prototype, I realized I had ended up with something formally named a trie, hence the name. I have no idea whether the implementation here or one resembling it has been done elsewhere. HN in HN trie container stands for host name because the trie is specialized to deal with matching host names, which is a bit more complicated than matching plain strings. And then it gives an example here where it says that www.abc.com is deemed as matching abc.com, essentially because it's a prefix. It's the former is a subdomain of the latter. A prefix with a dot, I guess. The resulting read-only tries, created as a result of using hn_trie container, are simply just typed arrays filled with integers. The matching algorithm is just a matter of reading and comparing these integers and further using them as indices in an array as a way to move around the trie. Okay, so this is some trie implementation. We have things like page size. What is this needle stuff? hn_trie counter is mostly a large buffer in which distinct but related tries are stored. The memory layout of the buffer is as follows. 0 to 254 is the needle being processed. 255 is the length of the needle. And then we have the offset to start of trie data section, offset to end of trie data section, and the start and end of character data, and the start of trie data section. Okay, so this is interesting. This is like the heart, I think, of why uBlock origin is efficient. I'm not going to look too closely at this, largely because based on the description, it seems like this is a homegrown kind of implementation, and that is, I think, it's probably going to be possibly hard to read and track, and I don't have like type information. So I'm not, and I don't have the ability to like click around. So I'm not going to be able to do a great job at like tracing through how a key is stored and whatnot. We have looked at various trees before, and I imagine that if you wanted to sit down and look at how this was working, it would not be too hard. It should look more or less similarly to the trie that we see on Wikipedia. I'm mildly curious about this BiDi trie. I guess BiDi is bidirectional. A BiDi trie is mostly a large buffer in which distinct but related tries are stored. The memory layout of the buffer is as follows. We have a haystack section, back to the haystack and needle stuff. A number of significant characters in the haystack. Offset to start of trie data, etc., etc. So here's a normal cell, aka cell. We have and, or, and segment info. And then in the boundary cell, we have right and, left and 0. We get the following internal representation. I don't know what and means. Go to and, go to or. If segment info matches, go to and, else go to or. Okay, so this is some other data structure. And I believe they have like WebAssembly implementations as well. We saw a WebAssembly folder that had BiDi trie and hn_trie files, if I remember correctly. Let me look at this again. So number of significant characters in the haystack. And then we have offset to the start of trie data, trie 0. And then trie 1, car 0 and car 1. Oops. So what do trie 0 and trie 1 mean? Trie 1 slot, trie 0 slot. So these are the variable names. And then let's just see if we squint our eyes if we can see anything here. So I don't know what 0 means or what add means. Segment info. So given the following of filters, assuming the token is add, I guess like advertisement for all of them. So we have dash images slash add dash slash Google underscore add dot slash images underscore add dot and underscore images slash add dot. We get the following internal representation. 0, I'm not sure what 0 is up to, but we have add down here. This top one, or maybe this whole thing maps to this cell here, which maps to 0 to 0 to 0. And then we have Google and /images. And I'm not really sure how to trace this and what 0 means in these contexts. But I'm sure we could figure it out and read the documentation and read the code more carefully. But I think I'm going to not look into it too much more. I think that really is the heart of the filtering algorithm. I guess like my initial impression is that we should make really sure that this data structure is A, optimized, and B, has well understood properties, because it sounds a little bit homegrown, whereas like tries in general are well understood. So there may be a reason to it may be a good idea to migrate away from homegrown stuff toward an implementation with well-known properties, even if just for like testing and safety and optimization purposes. Here's an MRU cache. We have a constructor. We have the ability to add a key. Remove key will remove the specific key you pass in. And when you add a key, this should be the function that kicks something out. So if we have the key, then we get found, and we set the value to the value. We set the key and value combination on the map. If we found the key already, we return. Although, okay, that means that the key has some value. It may not be the value we passed in. Otherwise, we check if we are in the max size, and if so, we pop from the array, and we delete the thing, I guess, at the end of the array, and then we call unshift on key. I'm not sure what unshift is. Add new elements to array. Okay, so unshift adds new elements to the beginning of the array. Okay, so we're adding to the beginning, and we're kicking off the end. And so, all right. So, then when we look up, then we should be doing some monkeying here. So we get the key. If it's undefined, we return. If the key is at the beginning of the array, then we return the value. Otherwise, we get the index. We call copy within to presumably move this to the beginning. We set array 0 to key. Oh, okay. We copy within must be sending what's currently in 0 to the thing that's now in I, because then we set the beginning of the array to the key, indicating that it's the most recently used, and we return value. And if I'm understanding this correctly, as we use things, they go in the beginning, but then when they delete things, we delete them from the end. And let's just verify that. Removes the last element from the array. Yeah. Okay, so if we're deleting them from the end and adding them to the beginning, then assuming the other logic is correct, then it seems like we're kicking out the least recently used, which would make this an LRU cache, right? And this here me look up what copy within is doing. Array copy within. Shallow copies part of the array to another location in the same array. So copy within start, target, end. And so we pass in what? We pass in 1, that's the start. We're copying from 1 to 0 and ending at I. So I guess we're copying the whole array over. Is that right? From everything that starts at 1. No, sorry, everything that starts at 0 and ends at I, we're copying to 1. That leaves a space at the beginning to put the key. So we're just shifting everything over to the right. But it seems like I don't know how a JavaScript array is implemented. How about JavaScript copy within running time? So what I'm wondering if this is a constant time operation or a linear time operation. I'll ask the AIs. Let's try ChatGPT. So tell me about the running time of JavaScript's copy within array function. The complexity of O of n. Whereas it seems like if you had a linked list, you could just add it to the beginning of the list in constant time and remove from the end of the list. So this seems like, just in terms of efficiency, this may not be the thing you want to do, but I guess they want constant time indexing into the array. But it happens on every key lookup, which would also, so maybe something like a skip list. But how is this not something that already exists? So let's see, most recently used cache. So last in, first out. Evicts the most recently used. So LRU deletes least recently used items first. Most recently used MRU discards the most recently used item first. When a file is being repeatedly scanned in a looping sequential reference pattern, MRU is the best replacement algorithm. Researcher, okay. Sure. Researchers presenting blah, blah. MRU cache algorithms have more hits than an LRU due to their tendency to retain older data. MRU algorithms are most useful in situations where the older an item is, the more likely it is to be accessed. Okay. I don't even remember why we were caching. And I'm not sure we saw in the code where this is called. But am I not understanding how it seems like as we get unless it pops from the so JavaScript pops from the end, right? The easiest way is shift to pop from the beginning. Shift everything to the left. I'll ask the AIs. Does this cache evict the most recent or least recent used entry? And I'll call it my cache, so it's not prejudiced by the name. It appears to evict the least recently used. When a key is accessed through add or lookup, it is moved to the front of the array. The front represents the most recently used item. When the cache reaches its maximum size, it is evicted. The oldest item at the end of the array is evicted. Yeah, that's what I thought. Let's ask Gemini. So does this evict the least or most recently used item? Yeah, so I think this is an LRU cache, not an MRU cache. Does it matter? I'm not sure. I'm not sure really what they're using it for. See if we can find out what they're using it for. Is it capitalized? I don't remember. So they're using it in cosmetic filtering. It's the cache of scriptlets. We didn't see scriptlets. I guess should we check out scriptlets? We have scriptlet filtering. And I'm going to guess that we have some stuff for like parsing scriptlets. There is some scriptlet directory. Was it in JS or in lib? Yeah, it's right here. We can load third-party CSS. Let's look at ePicker. We have this Vappy stuff, which I think is like graphics card stuff, right? Video acceleration API. Okay. So this is, I guess, checking if we have video acceleration. And what are we doing? Get element bounding client rectangle. Okay, so this is, I see, that's why we need like video card stuff. We're gonna, this is like maybe like the zapper. We're gonna pick a feature in the HTML. We're gonna figure out what the bounding rectangle is, and then we're gonna call get element bounding client rectangle, and this is presumably going to find the HTML element that is, I guess, closest to that bounding rectangle, and somehow let us block it. I think. Oh, no, this is the reverse. We're passing in the element, and then we're going to get the bounding rectangle of the element. Okay. And similar to things like highlight elements, merge strings. So these are, I guess, these are the sorts of things that are scriptlets. What about a subscriber? There's more Vappy stuff. We have this event listener on click. We're going to emit an event, like possibly a button, whether it's trusted. And then if we're clicking on something like an anchor element, then we just if it's not if it's not an anchor element, we return. Otherwise, if we're going to call on maybe subscription link clicked, it'll know what subscription means. But if that's true, then we're going to stop propagation. And here's on maybe subscription link clicked. And it has like some subscribe to adblockplus.org that is like hard coded. And I'm wondering if this is subscribing to sources of blocking rules for uBlock. I don't know, but I think I'm going to stop there. That's AdBlock origin. That was pretty cool. It seems to be a pretty, as a project, it's driven by a couple of fundamental data structures, mainly tries, which we've seen in other contexts where people deal with lots of strings. So I think they've shown up in compilers and related ideas. And so using these data structures, they're able to build up a fast ability to access and reason about blocking rules. And then it's just a matter of making sure that the user has a way of choosing which elements to block, to have a syntax for writing down how to reason about blocking elements. And then there's a bunch of functionality around things like subscribing to sets of rules, backing up your rules to the cloud, and that sort of thing. So that's uBlock origin. Thanks for watching.